Now I want us to take a look at how to do a ratio that actually has three quantities. What I'm starting with is actually two quantities. What we recognize is that there are 12 triangles and there are 6 squares. And so if we wanted to talk about the ratio of triangles to squares, we could say that it was a 12 to 6 ratio. But of course we know that 12 to 6 isn't the simplest way to write the ratio. We know that actually 12 can be divided into two groups of 6. And of course 6 is already in one group of 6. And so we could say that we have 12 triangles to every 6 squares. But if we wanted to say it in the simplest form, we'd say the ratio of triangles to squares is actually 2 to 1. But now we're going to try something new. Here's what I'm going to do now. You notice we've still got a 12 to 6 ratio of triangles to squares, which could be 2 to 1. I've ungrouped them, and the reason I've ungrouped them is because I'm actually going to now put a third shape in. We're going to have 4 circles. Now the reason I had to ungroup those from their groups of 6, we had 6 triangles, and 6 squares, which is how we got a 2 to 1 ratio. But obviously a circle can't, the 4 circles can't be put into groups of 6. And so let's talk about, first of all, we can have a ratio of 3 things. We could say the ratio of triangles to squares to circles is 12 to 6 to 4. And so this is a ratio with 3 quantities, and they show up all the time, and they're not a big deal. But I notice I can't group them as 6, even though 6 is the greatest common factor of 12 and 6. It's not a factor of 4. And so the question we have to ask ourselves is, what is the largest number we can put in a group and have equal groups of all 3? We recognize that 12 and 4 both have 4 as a factor. 12 and 6 both have 6 as a factor, but neither 4 nor 6 goes into all things. But I think we do notice that we actually have even numbers on all of them. And we know that all the even numbers can be put in groups of 2. And so here's what I'm going to do this time. I'm going to actually simplify this ratio by taking my 12 triangles and putting them in 6 groups of 2. And my squares can be put into 3 groups of 2. And my circles can be put into 2 groups of 2. And so let's see, I have 12 triangles, 6 squares, and 2 circles, a 12 to 6 to 4 ratio. But if I put them in groups of 2, I recognize I have 6 groups of triangles, and then I have 3 groups of squares and 2 groups of circles. So this ratio can also be written 6 to 3 to 2. And so if you're able to simplify fractions, then you're able to simplify ratios with 2 parts. And if you can do them with 2 parts, then adding a third really doesn't make it any more difficult.